Hey there, I'm Koshik from Robotics 101. Welcome to part 1 of my new 3D printed robot arm series. I've already made some significant progress on the robot, so the purpose of this video is to sort of catch you up on what I've done so far and what there's left to do. Alright, let's get started. So what I have here right now is the base for the robot arm. Pretty much you guys can see the internals of how it works. If I do a half section view here real quick. You can see that I have a stepper motor with the gear, and the upper base also has an internal gear, and when the stepper motor rotates, the upper part of the base will also rotate, and consequently everything attached to the base will also rotate. Now, there are some design flaws with what I have. As you can see, the way the upper base rotates is with this bearing right here, and a problem I found with this design was that when a lot of weight was put to one side, the whole base would tilt over. And an afterthought that I had was adding support bearings to, as you can see here, like these support bearings, which drastically reduced the amount of tilt that I ended up having. I have one in 4 corners. It's just hidden right now. You can see right there and there. But ideally, I'd have 2 bearings, like make this axle a little bit longer and have 2 of these bearings, which would really restrict the upper base from moving to any one side. So that would have been an upgrade that I could have made. And then for the upper base, I have an 8mm axle that goes through these 2 supports. So if I just show that real quick. And then this is the first arm. I have limits. I forgot to mention, I have limit switches on the base right here, and then this rotates with the upper base. So when I'm homing the robot, it'll know where its 0 position is. Really similar to how 3D printers work. And then for arm 1, I have this stepper motor with a gearbox attached. More on that later. With a 20-tooth GT2 timing pulley, and that'll be tensioned against this 3D printed pulley I have right here, which is 60 teeth. So that'll give me a 3-to-1 ratio, which would be really helpful for movement and such. And then I also have a similar system for tensioning the different parts of the robot right here, as you can see. So if I show you arm 2, it's the same system with the pulley and then the timing pulley attached to the motor. If you're wondering why this end stop is just floating around here, it's because I haven't really sorted that out yet. It'll be a simple fix though, so I'm just gonna hold on to that. And then on the sides, these are end caps. So the axles stick out slightly from the bearings, so I just have end caps to hide them, and then screw holes for those end caps. It's pretty much just the same system with the tensioning, and then the end caps, and the stepper motor. And then the last part of the arm 3, is this. Again, I have end caps, and then I have stepper motors with tensioning. And then this is sort of a temporary structure with the 2 axles and the bearings. So ideally, I'd have some like grippers attached to these, and I could have the stepper motor here rotate a pulley that would rotate the grippers. This is subject to change though, because I've come up with some better ideas that I think would be better. It'll allow me to have more grip when I'm holding various objects. But yeah, that's pretty much the whole robot, the CAD model of the entire robot right now. And I have all these parts printed, as you guys will see in a moment. So we'll assemble it and see what it looks like. Alright, so I have all my parts here. I have the electronics over there. I have some bearings to take out right here. Let's get all the parts out and get it assembled. So everything I have here right now are all the parts that you guys saw in CAD. So let me show you a closer look. Here's the base with the bearing installed. And the motor's underneath. And cooling vent. Upper base. The other cap that goes right there. Here are the 3 arms. Just a bunch of miscellaneous parts, experiments that I did with gears and grippers, and then end stops, and the end caps are also in there. And here's all the hardware. Here's one of the stepper drivers I'm using, and then I'm using an old 3D printer power supply that I'm probably going to upgrade. The brains of this robot are going to be this Raspberry Pi right here, and then here are all the stepper motors. And then this is just some extra hardware. These bearings are for the gearbox that I'm going to be using, which you guys will see in the next video. And then these are the 8mm axles, so here's just a closer look. Just standard 8mm steel axles. And then bearings, and then the timing pulleys. So let's get this whole thing assembled, and I'll see you guys in a bit. Alright, so here's the completed robot. I have the motors, as you can see right there, for each axis attached. Here's an extended view so you can see each one. I haven't attached this motor because it would just be there stationary, because like I mentioned in the CAD section, I don't really have a specific idea for what I'm going to do here. But I'll just show you guys a quick demonstration of just this axis moving. I'll just connect this up to my TB6600 driver, and I'll show you guys why I haven't worked on this robot in a while, or rather why I've been waiting to finish printing my gearbox, which is what those bearings over there are for. And the gearbox actually just finished printing, so I'll show you guys that. But essentially what's happening is the motor doesn't have enough torque, so when the arm goes past a certain point, it skips, which is to be expected because I'm pretty much just asking a lot from this motor. So a gearbox would make sense. Okay, so now I have the electronics set up for the motor. I have the power supply connected with the stepper driver and the Raspberry Pi, and I've connected it to my Mac running Boot Camp, and I have VNC Viewer, which is what I use to access the Raspberry Pi without actually having to connect the Raspberry Pi to the monitor. It's really convenient. But anyway, this is the code I'm using. I made my own stepper library. You guys can check out the GitHub. I'll have it linked in the description. I'm making my own stepper driver library for the Raspberry Pi, written in C++, because there isn't really one right now that's suitable for my needs, that has acceleration, etc., stuff like that. So, yeah. I'll show you guys what I was talking about before, where the motor wouldn't have enough torque to hold its position. So right now it's fine, and if I just run the command, you'll see it'll move fine. That's fine, and then this might fall. Okay, yeah. But then if I change it to go in the other direction, if I make it positive 300, and then you make the file, and then notice how it'll move fine until after a certain point it'll skip steps. I think next one, there we go. And you saw it skip steps, and the end stop mount prevented it from smashing into the base, but that's a serious problem, obviously, because if it can't even hold its own weight, how is the arm going to support any extra weight, which is an issue. So to solve that, I've printed a gearbox from Thingiverse that I think will work really well. I've printed the gears right here. I'll be assembling it in the next video, so be sure to stay tuned for that. Here are the gears, and then these are on my printer right now. Those are the parts for that. So yeah, so this is the problem that I'm trying to solve right now, and hopefully by the next video we can have it solved. So yeah, that's it. See you guys.